Good morning. This is Caroline Hazard with the Jump Into STEM team, and welcome to the second webinar for the Round 3 Challenge, Pushing the Envelope with Wall Retrofit Designs. We've got a great presentation today with Jonathan Benezry from NYSERDA, so let's get started. We're going to do a quick overview of Jump Into STEM. I've done this before, so we've got this recorded, but I'll do that quickly for everyone. I'll review what is our current challenge for round 3, and then we'll get into Jonathan's presentation. So let's get going. What is Jump Into STEM? Jump Into STEM is a student design competition engaging college students, university students around the nation to compete for internships at Oak Ridge or NREL. These are the national labs for the U.S. Department of Energy. We've already had 2 challenge series this fall that closed last month. They're in the judging phase, and this challenge is round 3. And all of the finalists from these challenges will compete in a final event in the spring where we will select the final winners for the 6 paid internships with Oak Ridge or NREL. You can visit jump.ideascale.com to learn more about this. So some of our goals with this program are to expand this program nationally. We started from a pilot in the Southeast, and now we're going nationwide. Our key component of this effort is to make sure that we are cultivating more influx of women and minorities into the STEM field. So we're doing some specific marketing to colleges and universities around the nation on that front. We're also trying to reach out to the colleges and university professors and academic departments to engage them in using the Jump Into STEM challenges as a part of their coursework and possibly as a bonus point. So we do have some colleges doing that. That's just great. And we look to expand that in the coming years. And of course, ultimately, we want to engage more of the creative thinking of students out there, the bright minds out there, our future, to ideate and advance buildings research and innovation. Let's go through a quick navigation of the site. When you go to jump.ideascale.com, you're going to want to go to how it works, right where my red arrow is. And there's going to be a video there that shows you how the site works, gives you an overview of how the challenges work and all of that. So that's a great place to start. Another thing to know about is under the current challenges section here of the home page, there's going to be a listing of all the rounds that are open, the challenges, round 1, 2, and 3. This is an older shot showing only just round 1. Right now we've got the round 3 challenge listed there, and that's what you would want to click to see more information about the challenge. When you do that click, you'll see a card like this that'll have the information on the challenge, resources you can review. You can scroll down to see more. This is where you'd find data, resources, any of the recorded webinars that we do associated with the challenge are posted here. So this is where you want to do all your work. And then when you're ready to submit your idea after you've thought about things, formed your team, and come up with what you want to present, you click the Submit Idea button, which is right up in the corner, and that'll take you to a form that's pretty straightforward. There's kind of 7 steps here that you want to follow. First, you select what challenge you're working on. Then you want to make a title for yourself. You can look at other ideas and comment on them or vote on them as you see fit. And then in step 4, you want to write up your abstract. This is a short summary of what your idea is for the challenge. And then you can add some tags for your challenge idea. And then this step here is important, step 6. You can click this browse button. The text here tells you about step 6. And that'll help you upload any files. It's a maximum of 25 megabytes. You can upload Excel, Word, PDFs, JPEGs, PNG files, and so on. So that's where you're going to upload the bulk of your idea. And then when you're ready, you click Submit. Once you do that, this will this will be how it displays. Generally, this is just a test example. And the moderators will review your idea, and after a couple days, we'll post it, just making sure that you're a bona fide response here. So that's that. Here's the schedule. As I mentioned, we've already had 2 challenges running this past fall, rounds 1 and 2. They're in the judging phase. We're right here in the early part of December. Round 3 has just opened, and it will run through to the beginning of February. Then we'll do some judging. All of the down-selected finalists will get ready for the April event. Any updates to our schedule can be found on the schedule page, which is a link directly from the home page or listed here. So with that quick overview, let me move over to talking about what is the round 3 challenge and what are we looking for your ideas on. So there's a significant issue that many of the researchers and industry are thinking about in the marketplace with a large building stock of existing homes that are 2009 or older. We have an immediate need to think about how we can improve them. Many of these buildings were constructed previous to energy codes. As such, they have high energy bills or uncomfortable rooms and health and safety risks, such as perhaps moisture issues or leaky windows, unsafe conditions. So with that kind of context, we're looking to get your ideas about how can we design cost-effective wall retrofits that will help improve these homes, bringing them to a greater safety and code basis, as well as meeting comfort and safety. So using a base case house of a single-family home of 2,400 square feet, built in 1975, we're asking you to think about what you would design for a wall retrofit product that meets local code. You want to think about using a specific code for perhaps the city or village where your university or college is, or you can pick one. You just need to specify that. And then we need you to address any material needs in the design of this retrofit product. The efficiency levels, how it will think about air tightness and moisture, things like that. So we want to see your thoughts on how this is going to demonstrate performance for these things, moisture and air tightness, as well as demonstrating improved energy performance so that folks can address those higher energy bills. So all of this is listed on that card that I mentioned when you click the button round 3 on the home page, or this URL right here. So that's a very quick overview of that. You can view the first webinar on that page if you scroll down, where we did go over some of the 101 on envelopes and how they work, building walls, including the windows. So this challenge, what are the dates you need to know here? Let's back up here. It opened on November 1st. You have until February 8th at 11:59 p.m. East Coast time to submit your ideas. We will have a 3rd webinar in our series. We're working on lining up a speaker for that, somebody from the field working on these issues. That looks to be scheduled in early to mid-January, so check back on the schedule for that. And we will post that update to those of you who are registered with the system, so check back. Now I'm going to shift over to have Jonathan present. This is the main reason you're here. And Jonathan is a senior project manager with NYSERDA and leads industry market development for the Retrofit New York initiative, which aims to create a self-sustaining market that will deliver deep energy retrofit solutions to New York's affordable housing stock at scale. Previously, he served as a senior engineer with Stephen Winter Associates, a research and consulting firm specializing in high-performance buildings. Before joining Stephen Winter Associates, Jonathan oversaw major capital improvement projects at Related Management across a statewide portfolio of multifamily affordable housing properties. Jonathan holds a bachelor's degree in civil and environmental engineering from MIT. So with that, let's welcome Jonathan. Jonathan, if you want to take yourself off mute, that would be great.
Okay, great. Hi, everyone. My name is Jonathan Benezry. I'm with NYSERDA. For a just brief background on NYSERDA, for those who may not know, we are a New York State authority. We offer many different programs in clean energy and energy efficiency. And our mission statement is to advance innovative energy solutions in ways that improve New York's economy and environment. So thanks for joining or listening in. So what we're going to talk about today, I'll give you guys a background first on the building industry at a high level and its implications on climate and climate change. We'll then talk about innovation in the construction industry and what that means for us. And then finally, I will get a little more specific on Retrofit New York, which is the initiative at NYSERDA that I'm involved in, and that has some relevance for you as it relates to this design competition. And you can move to the next slide, Caroline. Thank you. Next slide, please. So what you're looking at here is a fairly typical New York City multifamily building. And just as a disclaimer, if you will, our initiative is focused on multifamily buildings, whereas the Jump into STEM competition is a more single-family focused effort. But I think that you'll find many of the same principles will apply. And if you are feeling the motivation to take on a bit of an extra challenge, you might even be able to apply a solution that's designed for a multifamily building to a single-family building. So moving back to my presentation, you're looking at a fairly typical New York City building built in the 20s, pre-war, steam heating, it's uninsulated exterior. This is kind of bread and butter, throughout the city. And you have a lot of upstate New York buildings with similar construction. They're not maybe quite as tall and more timber framed versus steel framed, but similar types of building science principles apply. Next slide, please. And here you're looking at a 1920s automobile, so same era. And obviously, at the time this was considered very advanced. But Caroline, if you can move to the next slide, please. You have today are obviously quite different than the types of automobiles that we had back in the 20s. We've come quite a long way, both in terms of the design and the manufacturing process. So how these machines, these designed products actually come into fruition. Next slide, please. And so the issue with the building industry is that the same methods and building systems that are used to condition these buildings, to heat and cool them, are in a lot of cases largely unchanged. We see a lot of replacements of, say, building steam boilers in kind, despite major advances in the technology that is used to heat and cool buildings. Next slide, please. And so this is an issue because when you multiply that type of inertia and the practice of replacing systems in kind across the scale of a city and on towards the scale of our country, we have a very significant issue when it comes to high energy consumption and greenhouse gas emissions. So this is something that you've probably seen a lot of news about. You may be studying this, but we are faced with a crisis. We are continuing to build and consume energy, burn fuel at a rate that is really not sustainable because of the amount of greenhouse gas emissions that result. And the issue is that in the future, say 2050, a lot of the buildings that are built today will still be standing and operating. And so in order to really address the issue of reducing large-scale emissions, you have to address existing buildings. Next slide, please. So there's a high-level goal that New York State has adopted called 80 by 50, which means that by 2050, the state will need to reduce its greenhouse gas emissions by 80%. No small feat, will require very innovative thinking and some risk taking. It's going to require a lot of out-of-the-box type of solutions, and but we'll have to promote a lot of these high-level but very ambitious goals, and we are in our programs. Next slide, please. There are also interim goals of achieving a 40% reduction in our emissions by 2030, as well as reducing our electricity consumption by 50% by 2030, and reducing 185 trillion BTUs by 2025. So these are all goals that New York State has set out to achieve and is on its way to achieving, and many similar states throughout the country and also geographies outside of the U.S. have set similar goals. Next slide, please. So what do those goals mean for the building industry? It means that the existing buildings are going to have to reduce their energy use 50 to 70%. So that's no small feat. That's going to require replacements, upgrades of all building systems, not one or two, and not just separately piecemeal, but actually in conjunction, in coordination with each other. The best and the most persistent and consistent result across buildings at scale results when you address the building's retrofits holistically. So that means addressing the building envelope, which is what this DOE competition is centered on, as well as the mechanical systems and also on-site generation of energy. We also see that building codes are progressing and can drive some of these changes, but in order to complement and help advance the changes brought about by code, we are working to address these through market efforts as well. Next slide, please. So what do we actually need in order to get these retrofits of existing buildings at scale to happen? Well, first of all, it is optimal to address buildings with high costs first. The higher the cost, the better the return on the measures. That's energy cost specifically. We need products that can fulfill the role of multiple building systems basically at once. So you need a product that serves, for the building envelope, say, to both provide insulation as well as, and not just, high levels of insulation, but continuous insulation to prevent thermal bridging, as well as air sealing to reduce infiltration and prevent issues that result from unchecked moisture. And these products are in their infancy at the moment. They're still very much non-existent really in this country, and we need those products to be developed in order to find solutions that will reach these high ambitious energy and greenhouse gas emissions reductions goals. We are also, in addition to seeking out products that can achieve these goals, looking at the capital improvement cycles of existing buildings, meaning that taking advantage of the points in time when buildings are prepared to spend money to undergo serious renovations and rehabs. Next slide, please. So we do have some external references that support our goals to sort of revolutionize the way that buildings are renovated and rehabbed. A report submitted by McKinsey recently. McKinsey, for those who may not know, is a very well-renowned research and consulting firm on a national level. So they released a report that said that the construction industry is quite inefficient and has lots of room for improvement. Basically, kind of mirroring what I just mentioned in the beginning about buildings not being built much more efficiently, or the systems replaced within them not changing much since the 1920s. So we have actually that good cross-industry support. Next slide, please. And so there were a number of paths outlined in the report that could be followed to boost the construction sector's productivity. Next slide, please. So a number of these, as you see circled here, include improving the supply chain, improving on-site execution, and as well as the technology and innovation advances that we need. And so let's talk about what this means. Next slide, please. Here you see an image of two houses side by side, and this image is from the Netherlands, where high-performance retrofits have actually been happening for quite a number of years, for at least 6 or 7 years. And so they've actually been able to put these innovation pathways into practice. They've improved their supply chain as well as their on-site execution and their technology and product development. And that's resulted in retrofits such as you see here on this slide. There's a building on the left which was built in the 70s, as well as the one on the right, but the one on the right has been retrofitted in the last couple of years with a prefabricated envelope, as well as prefabricated mechanicals that are built into pods and shipped to the site, as well as solar panel arrays that are also prefabricated and installed on site. And what's happening in the Netherlands is that these types of retrofits are now happening at scale. There are a number of over 2,500 buildings that have been retrofitted, another 2,500 new construction buildings of the same typology, I should say, using the same principles that have been built. And another 20,000 of these are in the pipeline. So there's very good momentum there. And this model has been extended to the UK and France and a couple of other countries in Western Europe, and is what inspired the Retrofit New York initiative that I am now involved in, and that is now generating a lot of buzz in New York and beyond in the US. Next slide, please. So you saw a picture of a low-rise building in the Netherlands, which may be closer to the single-family type that the jump and STEM competition envisions. But the solutions, as I mentioned earlier, apply also to mid-rise buildings. So what you see here is a 4-story building, also in the Netherlands, that has been retrofitted. And the black box that you see in the middle picture here is actually where all the mechanicals are housed. So you have your domestic hot water heating, your heating and cooling heat pumps, your energy recovery ventilation, solar inverter, and also a control system and data output hub, all located within this prefabricated pod or module. Next slide, please. What you're looking at now is an example of a building in the Netherlands. This photo was taken just a few months ago. And the one on the right, the one on the left, excuse me, represents 1970s construction pre-retrofit. So this is before any work was done. The picture on the right represents a identical building of the same complex, but post-retrofit. So you see that that the solution keeps the building pretty much intact, but adds on the layers that help it achieve high performance, namely net zero energy performance. And as you can see, there are some terraces on the left that have been retrofitted to become interior spaces on the right to take advantage of the geometry of the building. So how has this been done? Next slide, please. So the program in the Netherlands, which is called Energy Sprong, and again, which inspired the Retrofit New York program, basically served as a convener to convene different actors within the industry. So the solutions provider industry of folks like engineers, architects, manufacturers, builders on the supply side, and housing agencies and owners of housing, private owners, on the demand side. Those are the two primary components of the equation that, you know, if optimized, can actually result in a self-sustaining industry. In addition, it's very important to also consider the financial sector which comes into play by providing funding or financing to these projects, as well as the regulatory agencies that govern both things like code as well as approvals for these projects. So Energy Sprong has been able to engage all of these sectors, as Retrofit New York is doing in New York, in order to catalyze these kinds of retrofit projects. Next slide, please. One key factor in being able to scale these solutions is cost, and specifically incremental cost, meaning the cost to retrofit a building above the cost of a rehab with a normal business as usual scope. And so we've seen that cost come down quite a bit in the Netherlands, from close to $150,000 incremental cost per apartment down to around $60,000 per unit. And that cost curve is still improving. We're still seeing gains, or really reductions, I should say, in the costs. Next slide, please. So now I'm going to get a little more technical. We're going to look at the mechanicals within these solutions as well as the envelope. And so firstly, what you're looking at here is a mechanical room. It's from one of the first projects in the Netherlands. It may look somewhat similar to a conventional mechanical room, where you have various systems all kind of bolted to the wall, you know, lots of ducting going around. The thing is that these systems are all installed by different vendors and maintained by different vendors. So you have a high first cost due to the, you know, multiple contractors coming to do on-site labor, along with high ongoing costs due to several service contracts to maintain these systems. There's also a lack of central ownership to maintain the performance. So you have a sort of the tragedy of the commons. Next slide, please. And what you see here is an evolution in the design of these mechanical systems in the Netherlands. These are what we call energy modules. And as I explained earlier, they have different looks here, but they all basically have the same function, which is to provide all the mechanical services needed in one shed, in one box. And so that is beneficial because it means that there's one vendor, one entity taking ownership of all of these systems, making sure that they all work together optimally, that they all perform, that their performance can be tracked and maintained, and it does result in better performance and lower cost. And the more that these types of innovative mechanical solutions are advancing, the better the performance, the lower the cost, and also the higher the scale that these can be rolled out and manufactured. Next slide, please. Here you see an example, or I should say really an exploded view of one of these energy modules. So you can see on the left, towards the top of the picture, there is an outdoor unit or a condenser, except that these are heat pumps, so they can serve both as the indoor or outdoor unit. And you can see various other systems all throughout the module. Next slide, please. So what you're looking at here, now moving on to envelope, is a conventional installation of a facade solution, so a building envelope solution. This is an EFIS solution, EFIS being exterior insulation and finishing system, and you have a conventional construction crew applying it. And this is all fine and good, except that this doesn't push the envelope. This doesn't move the needle. The cost of this kind of implementation is high because you have a lot of on-site labor. And these on-site laborers, as good as they are, still have a non-negligible error rate. So you'll see errors or inefficiencies in the installation itself. Things like joints, connections can be suboptimal and can fail prematurely. And so you can see not just suboptimal performance, but maybe more importantly, a variability in the performance of these solutions. And that is an issue because so I spoke earlier about the financial sector. In order to get these solutions not just familiar, but accepted by the financial sector, these solutions really need to perform not just very strongly and at scale, but consistently. We need to see consistent performance that can be relied on and tracked and measured over the long term in order to really pull in the banks, the lenders that will be so crucial to providing the necessary financing for these solutions. Next slide, please. So what you see here represents an innovation in the facade solution industry. This is a picture of a factory from the Netherlands where facade panels are manufactured, and these are manufactured and then shipped to the construction sites where they're installed on site. So you can see the robotic arms on the left picture piecing together these panels, and on the right you can see that there are window openings built in. So this results in a lot more conformity, consistency in these products themselves, which reduces the errors and inconsistencies on site. Next slide, please. So here is a picture of the facade panel being rigged onto the building. Next slide, please. And here's another example, another picture of the on-site work. As you can see, most of the facade panel comes pre-built. There is some nominal work that does need to be done on site, obviously connecting it to the existing building, making sure it connects seamlessly with the rest of the panels, and that the energy module on the left, as you see there, can also integrate seamlessly. But the on-site labor is markedly reduced, the performance is improved, and the cost is also driven down through scale and through efficiencies that can be iterated on at the factory. Next slide, please. So now that I've given you some background on what the issues are and where we're seeing promise in the industry, let me tell you a little more about the Retrofit New York program. Next slide, please. So Retrofit New York issued an RFP about almost a year ago. That's a request for proposals. So we basically called out to the industry and asked for pilot solutions to be applied to actual buildings in New York State. And so we have since actually vetted all the proposals that came in, and through a competitive and publicized process, we selected 6 projects, 6 solution provider teams that are designing their retrofit solutions for multifamily buildings that are or designed to be achieving net zero energy performance. They connected with 6 existing building owners. So these are real projects that are in design right now, and will eventually, our hope is to build them all so that we can learn the most about them. We're also, just to give you a sense of the potential scale and also the response from our industry partners, we're also working with the State University of New York system to retrofit one of their university dorms, as well as the New York City Housing Authority, which is the largest owner of real estate in the country, with 178,000 apartments. And so our goal is to, by mid-next year, have a set of robust solutions that can be built and financed. So we're not just testing the technical solutions with these pilots, but also the financial solutions. And it's really our goal to continue this sort of effort. So it's not just 6 pilots, but we're going to keep going and keep offering, keep calling to the market through another 1 or 2 or 3 RFPs, however long it takes. And we're going to continue working with industry to build solutions until we reach a point where these efforts can sustain themselves. Next slide, please. So how are we doing this? So we are really similar to Energy Sprong, serving as conveners. We're not actually building anything ourselves. We're not designing anything ourselves. Retrofit New York and NYSERDA are serving as a catalyst. And so again, we're bringing together all these disparate aspects, disparate sectors of market and industry, working with financial sector, working with regulators, holding all kinds of events, roundtables. It's quite broad-reaching, and it needs to be in order to make these retrofits a reality. And so you can see here, there's the design and construction community sector that I've highlighted in green, which I think encompasses the sector that a lot of you may see yourselves in. And so it's very important that we have the types of innovative thinkers and problem solvers from that industry working on this, along with the manufacturers and builders, and along with the lenders and regulators and housing owners. So I guess I'm trying to say that, know that you can occupy a very important role. You can play a very crucial role in this market transformation. You can advance 2 slides, please, Carolyn. And just again, to give you a sense of scale, there are 1.7 million units of affordable housing in New York State, and they're operating, many of them are operating on a 20-year cycle. And so we have done a back-of-the-envelope calculation and estimated that if over the next 20 years, all of these units are retrofitted, that results in a $1.2 billion market annually. So that's an effort that could not only be really impactful, game-changing, for you and others in this design and construction industry, as well as all the other sectors. It could actually be quite lucrative. Next slide, please. So now let me tell you briefly, as I wrap up here, a little more about the types of solutions that we've solicited. Next slide, please. And given that these are quite unprecedented, and also that we, NYSERDA, aren't the ones designing the solutions, we've kept our specifications, if you will, to a high level. So what we've called for is solutions that achieve or approach net zero energy. We need the solutions to be cost effective, and so that I'm not sure how much into the budgeting and costing this jump into STEM competition will get, but it's important if the solutions are to be realistic and applicable. The solutions should also improve the aesthetics of the building, as well as improving the quality of life for the tenants. Next slide, please. Additionally, they need to be installable with residents in place, meaning that we are not expecting solutions to displace anybody living in the building, so that, for one thing, it doesn't cause any kind of resistance or backlash, but also because we want these solutions to be reachable at scale. And so there's really no way to scale these types of solutions to thousands of buildings, every year, if in every case or application the residents are moving around and moving from building to building. And so what that means is we need on-site labor to be reduced, just like in the Netherlands, where much of it is taking place off-site in the factory. And so that when you reach the site, all you're really doing is fitting large pieces together. But more or less, you can be in and out of one of these low-rise buildings within a week. Next slide, please. So what you see here is I've basically excerpted the specs, if you will. These are sort of the technical definitions of what we have been looking for. And so we're looking for a site UI of 20 kBTU per square foot per year. This is an aggressive figure, but it's also something that has been achieved through passive house design and construction, just not generally with existing buildings. But we're really looking to push the best and brightest out there to come up with the solutions that would achieve this. And we think that to kind of best guide the solutions on how to dimension their envelope, that the heating and cooling load should not exceed 11 kBTU per square foot per year. That's to make sure that you don't end up with a sort of an inefficient solution that has lots of solar on it, because we want these solutions to be widely applicable. So not just low-rise, but also high or mid-rise and higher buildings that may not have as high of a roof space to floor area ratio. And we stipulated minimum levels of comfort and service in the buildings to make sure that these solutions wouldn't result in uncomfortable buildings, which would obviously not be a sustainable situation. So let me mention that through our design process that we're actually wrapping up in a matter of weeks, after which we'll hopefully be moving on to construction, we've come to understand that there are a number of gaps in the marketplace in terms of innovative solutions. And specifically on the prefab envelope side, we need to find more of these, we need to encourage more of these types of solution providers to arise in the US. And so it would be interesting to see what kinds of plans and designs and solutions you can come up with that might actually be applicable to the real world. We also are looking for the same types of innovative solutions on the mechanical side. Next slide, please. So here you see 3 of our projects from New York City. Next slide, please. And here you have 3 of our projects from upstate New York. So the New York City projects are mid-rise buildings, and the upstate New York projects are low-rise buildings. Next slide, please. And this is the last slide, so this will be the conclusion of my presentation. So through the course of time over which we've been designing this program, and then since have launched our first RFP and worked with these 6 project teams to design various solutions, we've seen a lot of interest, and even beyond interest, demand for these types of solutions elsewhere. So not just for retrofits, but also in new construction, we're seeing a lot of interest towards using the same kinds of principles and solutions. We are working with people in Canada, both in British Columbia and Ontario, as well as government agencies in California and Massachusetts, to help with their own development of programs to encourage similar solutions. And as well, in the green, you have organizations representing various sectors of government agencies, as well as the SUNY system and the NYCHA, the New York City Housing Authority, groups that I mentioned earlier. So there really is a growing market for these types of solutions, and it's a effort, and it's a market that you can actually be a part of. You, if you choose, could become a solution provider, providing designs or even build solutions for these projects, or be more on the R&D side, working to look into the materials and components that will fuel these types of advances. And I sincerely hope that some of you do take that effort on. That's all for me. Thank you all very much.
Great. Thank you so much, Jonathan. Really great thoughts here to think about, looking at some of these examples across the nation, and even over the big pond, over looking in Western Europe, to see some of the examples that they've got there, and use that as a launch pad to think about how you might respond to this challenge. So if you have any questions, feel free to go ahead and type them into your chat window. I'm actually going to go over to the website for a second. I was going to show you, this is how you find the challenge. You brought up something, Jonathan, that maybe want to share this with folks. You pointed out the thought about cost effectiveness. Now, this is a big challenge, trying to figure out how in this single family home market to make this cost effective. Obviously, at scale and multifamily, it can be a little bit more cost effective with the many more buildings to work on and themes and all of that. So for this challenge, you can see here the 5 things that we're looking at, and we do bring up the thought of reducing costs associated with your solution. So, but this is one or more of the following. So, think about that, because that is a very challenging thing. So, we need you to think about the code. We need to think about how the wall or retrofit solution will use different materials, a clear explanation of how it's not causing problems with moisture, and how it addresses air tightness, and so on. So you can read that there. Just while I'm here, this is where you'll find previous recordings and the like. So, and then some great citations here. So, Jonathan, maybe if you're on mute, take yourself off mute. I was just curious if you had any suggestions on good resources. I might go back to your slide here. If any of these organizations might be good sources of information for people to ideate. Any thoughts on that?
So
examples or?
I think the best source of information, if aside from our own website, you can go to NYSERDA.com. I believe, I'm not sure if it's .com or
I think it's .org.
It might be .org. I'm not sure, but we certainly have a lot of information on this program on there. But the other place I would point to is the website for Energy Sprong, which is the Dutch program. And that's energy spelled with an I-E, so E-N-E-R-G-I-E, Sprong, S-P-R-O-N-G. There's a ton of information. There are lots of YouTube videos showing the on-site construction. all kinds of resources that I would highly encourage you to look into. They've been going with their program for quite a number of years, and so there's a lot more progress and information to be had.
Great. I'll go ahead and add those two links to our website so folks can find those. So I really appreciate that. So just to wrap up here, again, I showed you live how if you scroll down, you find more information. So do go there for those links. This is just a little plug to join us at ASHRAE on Saturday, January 12th in the morning. Melissa Lapsa from Oak Ridge National Laboratory and Dr. Roderick Jackson from the National Renewable Energy Laboratory will be on hand to talk about the Jump into STEM program and this challenge. They'll be there to answer questions about the laboratory and the opportunity for these internships at the lab. So do join us there. You can register at this link that's listed. So with that, I want to thank you for joining us today, Jonathan. I really appreciate all the wealth of information you shared. It's inspirational to hear what New York is up to, leading the way in thinking about how we can get to net zero. And have a great day. Thank you.
Thank you.